Hello, everybody. Okay. I just went to the bathroom and I'm at school, so I had to wear a mask, but there's no one in my room right now. Okay, I'm just getting myself situated. Hi, everyone. My phone needs an update. How do y'all know that? Really? Is it showing on your screen that my phone needs an update? I have no idea what you mean, but yeah. Welcome, everyone. Sorry, I was just taking a bit to get us started, but I think I'm setting myself down. Okay, awesome. Let's go ahead and jump into taking attendance. Okay, we got mostly everyone. Okay, let's jump into our check-in, everyone. What was your favorite toy as a child? Is the question here today. Let's think about that and let's put it in the chat once we're ready. I see a few of us are ready there. And then I'll check it out right now before I get too into it like I always do. Okay, we got a bunch of favorite toys as a child. Oh. Let's see. We got Monster High dolls. Real baddies play with Monster High dolls. Did they? Well, that's probably a toy in your time, not my time. We got Legos. Legos has always been around. We got Barbie dolls, Bambi stuffed animal. Oh, that's cute. Hot Wheels, Pop the Pig, Littlest Pet Shop stuffed animals or horse toys. I had this electric scooter that I'd be zooming on. Oh, that's fun. And we got Legos for sure. Man, I kind of wish I had some Legos now. I mean, those look fun for little kids. Actually, even for adults. But oh yes, Rosa, we got one finally in a Christmas time. We always one time me and my older sister wanted an easy bake oven, but we never would get one. And finally, my dad brought us um he brought us this cooking thing with like fake plastic foods, and he thought that was the easy bake oven, and it wasn't. And we were like so sad, but then we ultimately did get the easy bake oven. Yeah, it was fun. And then there's another Littlest Pet Shop video game I would constantly play. Beyblades, have no idea what those are. Oh my gosh, y'all had some great toys. I was gonna say Slinky, everyone. When I was a kid, I would play with the most basic toys. Like Slinky would be one of my favorites. I don't know why I would get into like or slime. You know, like those slime stuff that they sell at the store. I would play with it and it'd get lost, or my parents would throw it away because I would put it on the carpet. Wow, you guys had some great childhood toys. We got cars like the tiny Hot Wheels. Those are fun. Wow. I have no idea what Beyblades are. I'm gonna have to look those up. That sounds fun. Okay, y'all. While I'm looking that up, oh, I like stuffed animals and Bratz dolls. And I always wanted a Bratz doll and never got one. I just sometimes we get Barbies. I also like those little fake hamster things. I used to have a Hamtaro, those tiny little Hamtaro toys. We got Tech Decks. Don't know what that is. There's a bunch of toys I need to look up. I gotta look up Beyblades and Tech Decks. I don't know what Zuzu pets are. I had a Hamtaro, it was a little hamster toy, and it has like a little like you could collect more Hamtaros, and then like they have a little house. It was fun. Does Nintendo DS count as a toy? Hey, let's count it. That sounds fun. We had buckets of Hot Wheels. Still has them. That's hilarious. Okay, y'all. Let's see who we're missing, so I could make sure I am accurate. Okay, I am missing James. James and Grecia. James and Grecia. Let me know if that's accurate. If it's not, we could correct it. Whew. Okay, everyone. Thank you so much for sharing. That was fun. It brought back some memories. I still want to play with those toys. Oh wow. Brothers, so a lot of you had some DSs. Yeah, I don't think I've ever did. I always thought that was cool though. For those of you who don't know, I'm at the school right now. Actually, I'm in my classroom. Um, it has been feeling still some surrealness, and I haven't yet had a break to process anything. But it turns out on Friday I agreed to do hybrid teaching, so here I am. This whole week is going to be training, so I get actual students come in next week. So um, pray for me, hope for me. I don't know how this is all gonna work out, but let's let's what building? I'm in the commons. Um I'm in the commons, the commons is basically, so I'm in the same building as you, Rosa. Yeah, I'm in the same building, but you are on, I forget where Miss Ravon is at. Y'all are on like the second floor, perhaps. Yeah, and I'm in the first floor, but you have to go all the way down straight, and then my class is here. We call this the commons. Yeah, yeah. I need to figure out if these heaters still work. I'm pretty sure it does. I remember a lot of students would turn it on. But yeah, so that's interesting. So just so you know, that's why I'm a little bit like flustered a bit, but yeah. Yeah, I think Miss Ravon's on the second floor as opposed to she used to be in the basement, right? That the basement was that exact class that Miss Ravon had last year, when we were in person, was my first classroom. So I don't even know why that's a classroom if it has no windows. It needs air down there. But yeah, okay, y'all. Let's go ahead and get started with our agenda here today. So here's our agenda. I just took attendance. We're going to continue our talk on the integral from last week. Then we're going to have a checkout. And what? The next asynchronous is not due Friday, my friends. This is due Wednesday. Oh, I'm sorry. Asynchronous number 9. Actually, hold on. Let me just double check this. Here is our AP. I am pushed. I pushed asynchronous number 8 to be due today instead of last Friday. And the next one, async 9, is due Wednesday. So let's just go ahead and I'm gonna set this reminder for 8 for today. This one is due tonight. So I pushed it back so we had some more time. So due tonight. And then feel free to if you want to go over anything from that, feel free to text me and remind. I'm happy to, talk about any of that. So that is where agenda is at today. Oh, okay. Async 8. Yeah, don't know if I built in time for reviewing async 8. So someone just asked about asynchronous number 8. Oh, actually, I think, yeah. So feel free to text me. I don't think I built in time. So I'm wondering if, like, there's another thing, y'all, that you don't know, but because of the training that I'll be doing tomorrow, we're gonna actually have a sub for my class today. Like, so you know how y'all meet me tomorrow at 1? We're gonna be having a sub. Um, and okay, we're gonna also have a Desmos lesson today, and I'm just trying to think about this. I mean, we could start with, because I already had 2 students ask me about a little bit about this homework assignment, which is tonight. Let's go ahead. Can you we put at least one? Go ahead and tell me one of these that you'd like to talk about, and then we'll start our lesson today. Because we're getting questions on the homework, let's do that. If that sounds cool, y'all. So we're gonna do quick homework check-in. And then we could have some more time on Thursday as well if you all feel like that would be beneficial to check in on that homework assignment. Totally. So let's see. Lord, I don't know how to do the math. I need to see a demonstration. The first one, I really don't get it. Okay, so we have vote for number 1 on this homework assignment. Anyone else would not doing number 1 help us, or would another one? We got 1 and 3. And then we have, that's a sigma notation, right? So any would be good. Okay, so far I got 1 and 3. I think we could fit in 1 and 3. I could kind of get us started. That would be cool. Yeah, let's do 1 and 3 then, y'all. So feel free if you want to open this up together with me. This is here due today. Yeah, today, tonight. So we have this one and we have this one that we're going to try to do. And if y'all notice, if you look down here, we have the answers, but the goal I said is for you to show me how you use geometry to get to the answer. So for number 2, the answer is 17.5. For number 4, the answer is 18 pi. So this is what we have. Oh, I'm sorry, number 4, my bad. Number 3, right? We said 1 and 3. For number 3, the answer is 8. So we're going to be doing 1 and 3. Here's how I would go about it, y'all. I am going to go to Desmos and I'm going to graph the function. And let's focus on number 1. So the function for number 1 is just 5. Basically what that means is you have y equals 5. That's our function. So I'm going to go to Desmos and first graph it. So desmos.com. And then the integral symbol, right? On Thursday, we talked about what the integral symbol kind of means. The integral basically means, well, we now learn that it means to find the area under a curve, as well as having some connection with antiderivative. So I went ahead and I graphed y equals 5. Lo and behold, it's a nice straight line. So then in my mind, I'm thinking, oh, are we trying to find the area of a rectangle? If so, that's going to be very nice because that's easy. It's a rectangle. I know that it's base times height. Then go back. Okay, but it's specifically telling us to find the area, and I know it's tiny. So let me zoom in. Find the area between 3 and 7 on the x-axis. So I'm going to go back here, and let's find 3 and 7 in our visual. So 3 is right here and 7 is right here. So virtually what we're being asked to do is find the area under this rectangle from 3 to 7. And you could imagine, if you'd like, I'm shading in this whole area. That is what we're trying to find. Let's see, I see some stuff in the chat. Do y'all know the area that? Oh, so we have, okay, actually this is a direct message. The height is 5, right? I think the height is 5, yeah, because that constant 5 is up there. So then we have, oh, so it's 5 times 4. Oh, that's how it's 20. And then Edgar put 4 times 5. That's right, y'all. See how I used geometry to prove the answer? That's what you would show me in your homework. So remember, last week we learned that this integral symbol right here now has a new meaning where it means find the area under the curve now. And it gives you usually a function that you have to look at. So that is how we do number 1. And basically how you would show me, you could either sketch it on a piece of paper, take a photo, or you could just insert Desmos screenshots. Though it's gonna be kind of hard because I have a little zoom annotation tool. So it's up to you how you want to kind of, I know you've all been very unique in the way y'all show your work. You want to do it on a piece of paper, that's okay. And then we have, what is the integral symbol? So this elongated S symbol right here is called an integral. Have I just been calling it elongated S? Elongated S symbol is called an integral. There's my little adjustment. And remember, we first encountered this symbol when we were finding antiderivatives. But on Thursday, we saw that this symbol is also connected to areas under curves. And yes, it did have to do with Rosa mentioned the sigma notation. It had something to do with that. If you go back to our slides, and I think I'm going to recap it, but or if y'all like, if y'all want to be patient with me, I could just go ahead and show you what I mean. So on Thursday, kind of like when we wrapped up day 4, and it's great that we're having this side thing happening here today for us because it's good. It's good to have some real-time adjustment on the lesson. I'm gonna go back down to where this was from Thursday, y'all, where we kind of connected, and it's loading for me. The Wi-Fi here is not as great as the Wi-Fi was at home for me. But last week we were looking at sigma notation and how it connects to rectangles under curve as a way to estimate areas, right? And let me clear my screen so y'all can see this. But the more rectangles, the better your estimate was what we concluded. And we figured out that actually when you have an infinite amount of rectangles, or if you include a limit in front of your sigma notation, you get the exact area under the curve. And the exact area under the curve is this notation right here. This symbol right here, this elongated S, is called an integral. And that's where we kind of left off when we talked about our application on how to use that to determine exact areas under curve. So that's how it's kind of connected to today's homework assignment. Let me check out what's in the chat. Yes, perfect. So it's between 3 and 7 due to the symbol. 5 is the f of x. Yes. And we have your recording class, right? Yeah, I was verifying that right now. I am recording class. So it represents what the area is between. That is correct, Juan. And we could go ahead and do, oops, my bad. So that is correct. We could go ahead and do the other example as well. So the other question y'all had was about number 3 right here. So absolute value of x plus 3, and we want to find the area of this function between 0 and 2. That's what this is telling us. So let's go to Desmos. Let's figure out the graph. By the way, if you're able to hand sketch these graphs, that is awesome. So the function here is the absolute value of x plus 3. Look at how the absolute value looks like, y'all. It looks like a V, an absolute value graph. Oh yeah, usually you could put y equals like that. And let me go back because I forgot. Okay, it says, what is the area of this function from 0 to 2? So from 0 to 2. And if anyone from the chat wants to remind me what the answer was for this one, that would be awesome. So 0 to 2, my bad. I'm trying to like circle 0 and 2, and then my thing is not.
Miss Adano, you can put in x equals 2 and it'll make an automatic line out for you.
I could put x equals 2?
Yeah, like on the second thing, and then it'll make a line for you where you want it.
Oh my gosh, thank you. Yeah, you're right. Thank you. Yes. And then the other one at x equals 0, right? Yeah. Let me make them both green. Oh, that's a great way for y'all to show your work then. And then what we have essentially, thank you so much. That really helps. So then essentially what we're trying to find is the area under this curve, right? And this curve, in this case, it's a line, right? Sometimes you will get an actual curve. Basically looks like it's a elongated trapezoid is what it looks like we're trying to find the area of in this scenario. So if I'm shading it all in, elongated trapezoid. And what we could think of this, if you don't remember the area of a trapezoid, I mean, you could definitely, if anyone wants me to try it, I could. I don't know why I struggle with trapezoids, but I like to, oh, thank you, Shannon. So the answer of this is 8. Okay, so we should get an area of 8. For some reason, I like to break this up into a triangle and a rectangle because I see that. I don't know about y'all if you want to, I don't know what the area, can anyone look up the area of a trapezoid? I know it was like B1 plus something, but I separated this into the area of a triangle, and then here we have a rectangle. because I know how to find those two areas, and that's how I see it, but you can also do the area of a trapezoid. Yeah, you can break it apart. So that's how I broke it into a triangle and a rectangle. Well, let's figure out the rectangle because that's straightforward. The base is 2, my height is 3. 2 times 3 gives me an area of 6. Awesome. And then the area of a triangle is 1/2 base times height. So 1/2, my base length is length 2. My height of this rectangle from 3 to 5, right? From 3 to 5, that's a length of 2. So my height, so 1/2 base times height is going to be this. So basically what we have is 4 divided by 2, which is equal to 2. And then Shannon put that the area of this should give us 8. We have the area of this rectangle 6. The area of this triangle is 2. 6 plus 2 does give me a total area of 8 as my answer. So see how I'm hoping that helps, y'all. Does that help? I'm hoping. So that's exactly what we're doing, and that's how you do these calculations with an integral. You're being asked to find the area under these functions using geometry, kind of like triangles, rectangles, trapezoids, if you will. Yeah, so let's see. Does anyone have any additional questions before we jump into today's stuff? Okay, it helps a lot. How do we start 4? Just like, how do we get started? Okay, so there is a question on how do we start on number 4. So feel free if you need to take a screenshot or take a picture on your phone of this example I just did of number 3. There is a question on how to get started with number 4. And the answer to number 4 was, I know it had something about a pi in it, so maybe that's why it's kind of scary. So look at, because it has pi. Let me clear my screen. Thank you for this. Yeah, this really helps. I might use it again. So y equals, let me go back to the homework. Okay, how to get started with number 4. You're trying to find the area from -6 to 6 of this, the square root of 36 minus x squared. So step 1, go to Desmos and let's graph it. So square root, I have to use these symbols. And they said x squared minus 36. Was that correct? I feel like something's wrong. Oops, it's 36 minus x squared. No wonder I knew something was off. It's 36 minus, there we go. That makes more sense. It makes more sense because I know they said between -6 to 6. Do y'all know what this shape is? I want to just ask. Do y'all know what this shape is? What shape is this? Okay, great. Rosa said half a circle. That is correct. Our goal is to find the area of this half circle. A formal way to say this, I just see it in the direct message, is semicircle. Rosa says, are we going to do pi? Well, yeah, we're trying to find the area under the circle. Let me shade what area we're talking about. So remember, you shade the area under the curve, like I'm doing right here. So this is the area I'm interested in. But when it comes to area under curve in calculus and in math, what we mathematicians understand that to mean, and y'all are mathematicians too, it actually stops at the x-axis, everyone. So this shaded part right here is the area you're trying to find. Now, Rosa, you said that it has to do something with pi. It does, but why? I wonder if anyone knows why. How do I find out the area of this semicircle? How do I find the area of a semicircle? Yeah, so Rosa says, you know it's pi because it's a circle. And the only way you find the area of a circle is through pi. Yes. Does anyone know what the area of a circle is, though? Can anyone tell me? Like, we could look it up on Google. Just somebody Google it. What's the area of a circle? And we'll just put it down here. Yeah, if you don't remember, just Google it. That's totally an option. We have 360 degrees mentioned. Well, 360 degrees is how much degrees are in a circle, close. Okay, Rosa, thank you. So if you search this up, y'all, just put area of a circle. You're gonna get that the area of one full circle is pi r squared. It has to do with its radius. And yeah, there's a pi in there. Now, that's the area for a full circle. If I want the area of a half circle, so the area of a circle is this. If I want the area of a half circle, all you're gonna do is divide this by 2. And this will be the area of a semicircle. So then what I want you all to do is to try it now. So I gave you some hints on how to get started on this one. And what I can promise is let's come back to this on Thursday because tomorrow y'all have a sub. I do have a lesson, I recorded it. So I have a lesson and there's a way to get credit for tomorrow, even though there's gonna be a sub. But we'll come back to problem number 4. We could talk about it on Thursday, but for today, just try an attempt and submit it. Try to see what you get. And I'm trying to I'm very interested to see what y'all come up with as far as figuring out this area. But we have the shaded region, so there's a way to get started, and we have a formula we can use. So yeah, I hope that helps y'all. Thank you so much for bringing this to my attention, and it's, so we could get some support on this homework. Okay. Let's go ahead and transition to today's plans, which is going to be starting on the Desmos actually. So let me go ahead and clear up my slide. Awesome. And let me go ahead and transition this back. So if you haven't yet, we are on day 5 today. We just did our check-in. We're going to talk a little bit more about the integral, which is what we're just doing right now. We're finding areas on the curve, and that's what the integral kind of helps us to do. So I'm back on our slides, and we kind of already did a little bit of a recap, right, of what we talked about on Thursday. So on Thursday, we figured out that this integral symbol is actually a way to calculate exact areas under curves. And that's, kind of what you're going to be doing on your homework that's due tonight. So that's where we left off on Thursday. And today, let's think about this essential question. So cool. We now know that integral is connected to finding areas under curve, but how in the world is it connected to the antiderivative? Because originally, we saw that symbol being used to represent antiderivative. So that's something I want you to think about before we get started with our lesson on the integral. So think about it for a moment and then I'll move us on. I am on slide 5. Okay, cool. So I hope you got to think about this. Let's go ahead and see how we're gonna see this is we're gonna review antiderivative real quick. So this is what I mean about the fact that we seen this symbol represent antiderivative in this manner where we had this rule. Remember that we had this rule to help us find antiderivatives. So let's review this real quick. Example 1. Find the antiderivative of 5x to the 4th dx. Well, let's apply this here formula for x to the 4th. So take a look. My strategy is I'm going to ignore that 5 right here. I'm just going to focus on x to the 4th and apply this rule right here. So x to the 4th is basically 4 plus 1 is 5 divided by the same 5. 4 plus 1 is 5. And then we have to add plus c. And then, okay, so I applied my power rule for the antiderivative, but then I got to bring back this 5 that was in the front. So I'm going to just place it here. Once I have that, something I notice can cancel out, and it's the fact that we have 5 divided by 5 right here. Cancel. cancel. And what we're left over with now is x to the 5th plus c. And I don't think I could simplify that further, y'all. That is my antiderivative. And notice again, you could test your antiderivative because if you take the derivative of your antiderivative, you get back the original function that's here with the integral. So that's example 1. Let's see if there's questions about this review here. Okay, awesome. Okay, example 2, let's get some more practice. Okay, let's say we're trying to find the antiderivative of the function x, just plain old x. One thing to remember about plain old x is the fact that it has 1 as its exponent. So then its antiderivative, we're just going to straight up use this formula. It's going to be x to the 1 plus 1, which is basically 2, divided by 1 plus 1. And then you got, don't forget your plus c. We kind of had a little bit of discussion about that constant. Well, we got to add it. This is going to become 2. And this is also going to become 2. And I don't think I could simplify this any further. Let's see. Yes, that is my antiderivative. I want you to notice how I've written my fraction. These two ways are the same, they're equivalent. So you can pull out this divided by 2 as 1/2, or you could keep it this way. Either way is going to be equivalent. So that is example 2, review of the antiderivative. Let me know if any questions are coming up for you all. This is how we've been using how to find antiderivatives in the past, right? And again, that integral symbol, that's why it's called power rule for integration. That's where we first seen it. And on Thursday, we finally have now seen the symbol once more, but this time representing areas under curves. So our essential question is asking us, well, how in the world does areas, how are they relating to antiderivative? All right, so cool. That was a little bit of review on how we used antiderivatives in the past. Sorry, let me clear this now. I'm thinking, why am I, what? Oh, okay. So now we're gonna jump into Desmos. No idea why this picture's here, but okay. The rest of the slides are gonna be Desmos. So we're gonna jump into Desmos to further investigate the essential question today. Essential question will come up again, but let's have about a minute to let's get logged into this Desmos, student.desmos.com. Here is the code. Go ahead and take a minute and I'm gonna join you all in about a minute, y'all. All right, everyone, I'm gonna join you all. Don't worry, I'm gonna have the code still available for us to see. Just give me a sec to join everyone on today's Desmos. So I have to go to Teacher Desmos. And great, it looks like we have about 7 of us in. Let me just join you. All right, at this point, I'm gonna go ahead and grab the link and stick this into the chat so that we all have access to the Desmos. Again, make sure your real name is in there so I could give you credit for today's stuff. We have Rosa, we have Juan, we have Sophia P, Sophia G, Edgar, Shannon, Stormy, Kaylin, Viviana. We have 9 students in. We're still waiting about for 4 more students. Let's get logged in. I mean, feel free to take a look at all the stuff we're going to be doing here today. But then I'll turn on the pacing, by the way. Okay, we got Shania, so we're waiting on 3 more students, I believe. No, 4 more students, my bad. Okay, now we're waiting for 3 more students. And if I don't see your name, I'm just going to send you a little message. If you could please get logged in for your credit. And let me know if there's any issues as to why we can't get logged in. Okay, cool. So I sent you a message. If I don't see your name on here, the link to get logged in, everyone, is in the chat. So I'm going to go ahead and get us started. I'm going to hit anonymize for our names and let us begin. So I'm going to turn on the pacing. So I'm going to select restrict to screen 1, student. So this is what you all see right now, everyone. Well, actually 3 of us are on here. I don't know where everyone else is at. So we got 4 of us are on here. Where did everyone else go? I don't know if y'all are stuck on another slide or something. Okay, so the essential question, again, once more, how is the integral connected to the antiderivative is what we're investigating here today. And let me get out of the student mode because this is student preview. Let's all go to slide number 2. Slide number 2, y'all. I don't know if this is like tripping or what. It's saying that there's only 1 student in. Let me know if there's any tripping on your end with the Desmos, everyone. But otherwise, I mean, there's going to be parts where y'all get to enter in some stuff. So let me know. Okay, so should be on slide number 2. And this right here, there's nothing to enter, just a little review of the application. So we started last week about using this integral symbol to find areas under curve. And specifically on Thursday, we found out, like we actually calculated the area of this here region. Sorry, it's in gray. And I believe what we found for this area of the region, and I remember that Thursday, I think Edgar had helped us with it. And again, remember, it's because it's from 0 to 2. That's where 0 to 2 is coming from. This is now telling us to find the area. It's basically what that integral symbol is telling us, and this right here is our function. So on Thursday last week, we found out that the area of this gray shaded region was 2. And how that was figured out is I believe Edgar shared with us that envisioning that this was like a big rectangle, and you know that 2 times 2 is 4. But then you got to divide 4 by 2 because a triangle is half of a square. And so that's how we got an answer of 2 as the area for this portion. So that was last week. Yeah, yes, the area is 2. That is correct. Or you could have used the triangle formula. But last week, how we talked about this was imagining that this was like a full square, take half of it, there's your area. So that was review. That's a little bit of reviewing this. And again, this is what your today's homework is going to be about. That's due tonight. So that's a little review. Let me clear my screen. I'm going to take us to the next one. So in the next one, let's review the application continued. So let's continue this review. So this is now telling us, okay, so here's our function. The function is y equals x. That's graph for us right here. And we have to find the area from 0 to 3. So here's 0, here's 3, we're going to find the area of this region. And once more, it's a triangle. Let's see if y'all know the area of this here triangle. Go ahead and feel free to put that in the chat. There's going to be a point in time when you'll get to try this on your own as well. All right, so I have 4.5 mentioned twice. An area of 4.5, and there's some work being shown. 3 times 3 divided by 2. 3 times 3, and then we have divided by 2. Let me know, do y'all agree? I think I agree. 3 times 3 divided by 2, that's going to be 9 divided by 2, which is indeed equal to 4.5. I agree. I feel like that is indeed the area of this. If anyone else has a question on how we got that, feel free to let us know, but the answer is 4.5, everyone. I agree. This was from 2 private messages. Cool, so see, we're getting a little bit more practice on how to apply what this integral symbol is kind of telling us to do. Now in the next slide, we're gonna have a participation point, everyone. So stay tuned. We're about to move over to that next slide. Let's go. Let me clear my screen. Again, if you need me to pause or need me to re-clarify, feel free to let me know. Okay, everyone, I'm transitioning this all to slide number 4. Now it's you do. So this is kind of a little process check for us that are logged in here. But let's go ahead and you try. Like, I have no idea why your picture is so tiny, but feel free if you need to, I'm zooming in for you. Now you try. You're gonna go ahead and try your best to enter in your work, but go ahead and find the area that this integral is asking you to do. And here's the visual if you need it. Let me know if anyone has questions, but that's what we're doing here on this particular slide. Let's take about a minute or two and then I'll see what y'all have. So it's you try now. All right, everyone, let's go ahead and come on back. Let's see what you have. I'm gonna go to my teacher mode. Let's see. I see 8, and then there's some steps there. I see you find the area between 0 and 4. The space is 4 times 4. So then you would multiply and divide it by 2, due to it being a triangle. The area would be 8 units squared. We have 8 question mark, 8. We got another 8 coming up, and then a few of us are still working. So let me go ahead and give y'all time, my bad, for you to fully go ahead and enter in your work for this. Because I know we have 1, 2, 3, 4, 5. I see 5 answers. So let me go ahead and wait a bit. My bad, y'all. All right, I'm gonna go ahead and bring us back here, y'all. So the answer for this problem is indeed 8. I do see it reoccurring here. So if you did not get 8, take a look at either you see some algebraic steps or you also see some verbal explanations. See, I like that. See how there's Grigory has like the mathematical steps written out nice and clean. Then we have Sophie on here. Write out the steps verbally. I also like this too. Take a look at this kind of train of thinking down here. Sophia K. So awesome. Okay, so it looks like we're in general agreement though, what I'm seeing here as far as our answers are concerned. Awesome. So let's go ahead and go into the next one now, y'all. The next slide. I'm going to transition us. And then after that, oh, can you show how you would put that in Desmos? Let's see. So I just got a little request here. Can I show how I would put that in Desmos? Like as in like how would I shade the area kind of? Or how I would put this in Desmos? So basically I would just open Desmos.com, a separate Desmos.com, the graphing calculator. I click there. And let me go back to the visual. So the function is X. It's simply just X. And what that means is they're not writing out Y equals X, but that's what it is. And they were asking the integral was from 0 to 4. So I think this was a cool strategy that I was just shown. So you could do this and it draws little lines for you. And basically how I would show this, like how I'm showing that the area is basically 8 is I'm shading in this triangular area right here. Now the shading that I'm doing is obviously my zoom tool though. But I can see like if you show me like with these lines and all that, I could see that you're showing me it's a triangle. So to kind of model what everybody was doing, I feel like a lot of us were kind of envisioning that this was a square and you just divide it by 2 is kind of how I seen it. So kind of like students did 4 and the height of this is 4. So you got, right? 4 and 4? Yeah. So you got 4 times 4, base times height. That is 16. But because this is half of a square divided by 2, and that's how we have been getting 8. So that was just for that question, per your question. This is how I would go on Desmos and put it in and kind of show my work as to how the geometry gets me the answer. So yeah, hopefully that helps y'all. Let me clear up my screen. Yeah, perfect, perfect. You're welcome. Let me clear up my screen and take us into the next slide. This is perhaps going to be the last slide. What's cool about this, y'all, is tomorrow I'm not going to be here. So I already mentioned that. So what I could do is I could finish my recording for this for you all, and you'll finish this activity. So that could be a plan for tomorrow, because this is super, super essential, everyone. Okay, everyone. So we've been looking at the very same old function so far. Now, I have no idea why it looks so tiny, but take a look at my screen. Let me zoom in. So far, we have done this first one. This was the one that we did in class on Thursday. We found that the integral from 0 to 2 of the function x, when we found that area, was 2. Then we moved on and said, okay, what about 0 to 3? We went ahead and found the area. Y'all found it was 9 over 2, aka 4.5. That was the second one. Third one, right now we just did the area from 0 to 4 of this function x, and we found it was 8. The question I have for you to enter into this box for your first participation on the Desmos is, are there any patterns that you notice? That's our question today. Are there any patterns that you notice? Go ahead and enter that here, and we'll check that out, y'all. So let's take the next minute or two on slide 5. All right, everyone, I gotta bring us back. So take a look at what y'all have here. So what's gonna happen, everyone? Let me stop my share. Is we're gonna continue and finish this tomorrow, and it will be for a grade. So jump on in tomorrow. Y'all have a sub. Let me know how it goes. I do not know how Zoom subs are gonna go. Let me know. Let's wish for the best. All right, y'all. Have an amazing lunch. I don't want to keep you up too late, but bye, everyone. Let's continue this. Bye. Have a great lunch. Bye, everyone.